By the end, you'll be able to make a faster, smarter call on whether to repair or replace and get your equipment back up and running sooner. Let's get into it.
Today we're going to discuss Origin, auto evaluation and validation tool for servo motors. This is a new product from Octava Engineering, and it is a complete 360-degree evaluation and validation of servo motors. It checks all 12 servo motor failure points, which are alignment, bearings, bearing bores, bearing journals, brake wear, brake backlash, feedback, encoder resolver, rotor balance, bent shaft, magnetism, winding, insulation, and thermal or temperature. So this will completely test a servo motor, and we're pretty excited to bring this new creation to you. So as we were discussing, here's the basic components of a motor. So all these are tested. Typically in the past, servo motors were just tested for alignment and encoder. And then everything else was done with different equipment. So this is all able to be done with one product and within one test. So it's a big time saver, especially evaluation on, say, incoming servo motors. It's an excellent tool for validation, like final test. So it really does a fantastic job with testing. So this is the equipment here that you would need. So the Linea X3 and the Runwell drive are our basic product for servo motor repair. And then the Origin here are these two sensors. So you get two sensors when you purchase the Origin system, plus cabling and the USB hub interface for the product. And typically small servo motors, just one sensor mounted to the pulley end, drive end of the motor. Once you get up a little bit larger, say a little bigger than a loaf of bread size, you would need two, one front and back. And then we also have a third sensor option if you want to test the device that's maybe attached to the motor, gear reducer, whatever. So right now we're going to begin a test, and then while the test is running, we'll go through some more information about the system. So here's our user interface for the Origin. So you would click on the Origin icon. You would put in the encoder type. So serial encoder, manufacturer is Nikon, encoder part number. This is going to be a Kawasaki motor R2A. And then you would enter, just like for final test, the servo motor information. So this is a 8 amp motor. Torque is 12. Continuous nominal speed is 3,000. And this motor has a brake, so 24-volt brake. Now the nice thing about the setup is on a lot of systems you need to know, balance and bearings and all this type of stuff. So ours is very simple. You need shaft diameter. So this is a 18-inch, and the kilowatt rating is 3, and then that's it. So you would click proceed to begin the test. So right now the software is loading the information we entered into the Linea X3 and then preparing the drive, the Runwell drive, for operation. Here's the test report template. So this is just a sample. So basically sample, encoder type, manufacturer, and motor information. So confirm that. And then this is the the basic testing screen. So you would hit Start Collection. This is a fully automated test, so the test will just go through all the different stages. Um, so it checks vibration, sound, magnetism, winding, encoder signals, brake backlash, and again, all automated test that will take probably around 15 minutes. 15-20 minutes is typically the average time for the test to complete. We won't sit and just watch the test. So you can see the motor angle has begun, so the test is underway. So right now we'll go back to go through the information. So inside the sensor, I guess back to the hardware, is signal analyzer, accelerometer, magnetometer. These are three-plane measurement devices: acoustic sensor, temperature sensor, of course the run-well drive, and then the Linex3 and the AutoQ Horizon software. And here's the test report. So you get full detail, just like on our final test for encoders and motors. You get all the data collected. So this advanced page shows all the information. Intermediate is kind of explanation, gives some detail to the report. And then the beginner is just our basic overview page. So it tells you, what's good, what's bad, how bad it is. So 90% on the encoder, pass fail, on vibration, magnetism, brake. So it gives you all the detail. So the vibration in that, it will get into severe, moderate, insignificant. So those are kind of the terms. Feedback device is excellent, good, weak. So those are the terms that you'll see on the test report. And then typically, here's some tests that were done by some of our customers. So they had a problem on their machine, wasn't able to repeat position. So they tested the motor, found that the encoder was out of range. You can see on the test report here in the highlighted area, a lot of variation in the voltage. So explains the bad positioning. They were actually able to just replace the encoder themselves and get the machine up and running. So it's a typical good application for the Origin test system. So right now the test is going through its standard process. So let's take a look at where we're at there. So right now you can see you got some sine wave on there. It's doing winding checks at the moment. And so once it completes, we'll review the details on the test report and see how everything looks. So right now it is doing vibration, so collecting some vibration data on this motor. So now right now it's going through some of the magnetism checking. It's capturing kind of magnetic pulses. These are measured in microteslas, and this will show up on the report as a kind of a flower petal arrangement, and then some sinusoidal type signals overlaid on top of each other. So we'll see those once they come out on the report. And here we have another form of magnetism testing. Again, this is rotational image. So there's two phases that happen. There's the pulse, and then this is rotational to capture the measurements. And right now the test went into high speed, so now it's running at full speed, which is where it does some of the vibration checks and some of the encoder signal checks. So it's now moved into the next phase. And here you can see some of the vibration signals, again at the higher rate of speed. So you get the getting pretty close to the end of the test now, so we should be seeing the report soon. And we'll go through each page and show you all the details of it. Beginner page, intermediate, and then all the raw data collected. All right, so here you can see the test is now complete. The report has popped up. So this is the template area, right? We filled in this information. And now it's going through kind of everything about the motor. Looking at everything, the motor looks in pretty good shape. So pass is the feedback encoder, 95, almost 96% health. The encoder is rated against new encoders. The alignment of the encoder is at 100%. And the vibration is looking pretty good. So normal on all the different things, front bearing, rear bearing is good, and insignificant on the wobble. So there's really good results on this motor. Pass on the magnetic field, the strength. So this is kind of just the overview. Tells you quickly what how everything performed. So we'll go through, see into the vibration information. So this is accelerometer. So we measure vibration two ways, velocity and accelerometer. Again, these are 3-plane, plus we do a comparative average on these. And there's velocity, and this is basically, this is perfect. Here's the acoustic information. So nothing, it's insignificant as far as the results there. So everything on the sound of the motor is also matching with the vibration of the motor. And then this is the magnetism. So this magnetism is a combination of the permanent magnet rotor and the winding. So you got this flower petal layout, and then these are the sine waves that I was talking about. You can see they're different. This is because it's 3-plane, so X, Y, and Z is checked. The strength, pattern, and duty are all good, so there would be a fault indicator if any of these were out of range. And then also here is the run mode magnetism, and you can see all three. So this line, it looks like just a single line possibly, but it is 3 colors like this magnetism raw graph, and you want to see those overlaying on each other very symmetrically. So this is a very good indication as well. And then this is the encoder. So there's no noise on the encoder. The signal is in the bright green, right on the edge of the bright green. So bright green is where it's excellent. And then once it gets to the pale green, it's good. Orange is weak, and red is replace. So, and you can look at both channels. This is a 2-channel serial encoder. So both channels looking good. And then this is the data from the encoder. So the report is looking really good. Winding, amperage, voltage, sine waves are all symmetrical. So again, looking Excellent. So back to the overview, but this is our test system. So I'll show you kind of what it looks like. So what I'll do is, just so you can see what the sensors look like, I'll pull up a couple images and share those with you. So when you get the sensor, if you're familiar with vibration sensors, they're usually something that you have to fasten mechanically. But here you can see ours is attached with Velcro. So um, new approach to vibration sensors, plus it is also in this case with USB connection, some indicator lights on here. But you strap the Velcro strap around the motor and you position this in the front or rear or both. So I'll show you how that looks attached to a motor. Let's see here. So here we got one attached to the motor. You can see the indicators here are lit up. So typically this is how you would mount it. So you mount with the connector more towards the center and the edge of the sensor at the edge of the motor. That positions the vibration sensor over the bearing, and on the front you would do the same thing. And these indicators here, so you can see this is kind of a green indicator. But if, so it's 1 would be the bottom here, if that was lit green. 2 by itself is zone 2, which is the rear of the motor. And then if both are lit, that's 3, which is your gearbox, your gear reducer. So that's how they look on the motor. But the nice thing about it is they're really easy to use. Setup is really easy. You just strap these around the motor with the Velcro strap and run your test, right? And then you can reuse these. A lot of times, like I was saying, the vibration sensors got to be screwed into something, right? It's just time-consuming process. Some need to be bonded, like epoxy. So really not friendly for doing multiple samples and multiple tests on various motors. So this makes it really nice and quick and easy to set up. So that is our system. So that this is, like I was saying, this is really excited to bring this new way of testing to the servo motor repair industry. Hope you enjoyed this, and thank you very much for your time today.
Now that you can spot a bad servo motor on site, take the next step and see what it's worth to you. Head to the ROI calculator linked below. Enter your own numbers and it'll show you the real savings from diagnosing equipment in-house instead of sending it out. When you're done, you can save your results as a PDF and share them straight with your finance team. Manufacturers using the system have cut repair costs by up to 50% and reduced troubleshooting and diagnostic time by as much as 75%.